We will be solving this question, which is single element in a sorted array. So let's read the question. I am given a sorted array consisting of only integers where every element appears exactly twice except for one element which appears exactly once. I have to return that single element which is appearing only once, right? And my solution must run in O of log and runtime complexity, and the space complexity should be O of 1. So here are two examples given to us. Let's see this example 2, 3, 3, 7, 7, 10, 11 and 11. As you can see, 10 has no there is no 210 in our array, so it is the single element, right? So I'll simply return 10 is the answer. So let's see some of the constraints. Nums.length is not going to exceed 10 to the power 5, and nums of I value will be in the range of 0 to 10 to the power 5. Okay, so since the array is sorted, right, definitely binary search, you might have think that binary search might be used for this problem, right? And you are totally correct, but the question here is that how am I going to know that where is my that single element is going to be present? So right, that is the that is the main goal here. So let's see a test case, which is this test case. Okay, suppose I have taken my start pointer, end pointer, and this is the mid value currently, right? Now one common thing I'm going to tell you, and that is suppose this is the this is mid, right? I will simply check my left guy, and I will simply check my right guy. If both of them the mid value is not matching with both of them, I can simply say that the num sub mid is the answer. Why? If it was the if it was not it was having a duplicate element, then definitely it should have present in either left, or it should have been present in either right, but it is not present, so it simply means that it doesn't has a duplicate and it is the single element in our num sub array. So I'll simply return mid. Num sub mid is our answer. But it can have edge cases, and edge cases can be like mid can be sometimes 0, and in that case I'm simply going to check, suppose this is a test case and this is the mid, right? I'm simply going to check my first element. If it is not matching, then I will simply return mid, and there can be second edge case, which is this mid is equals to n minus 1, the last guy. 2, let's take this edge case, okay? 2, 2 and 3, and my mid is this. I will simply check my second last guy. If it is not matching, then it simply means that num sub mid is the element that is appearing only once. It has no duplicate element, okay? So I will simply return num sub mid. Yes, and suppose all of these test cases, all of these statement get false, okay? So in that case, how should I decide that whether where should I move? Either I should go to the left side, or else should go to the right side. Where should I move? So that is the biggest question here. If I can figure it out, then I think it's a easy question. So let's see how am I going to know where should I move, right? Let's say this is 3, okay? I change just to make sure that you will get to know. I have to check my left guy and right guy, right? So now let's say okay, this is mid, okay? Now I will check first. I will check each of the test. I will check each of the condition. If if I will check if my left guy and it is not matching with the num sub mid, and my right guy is not matching with num sub mid, I will return the num sub mid. If it is the mid is equals to 0 and mid is equals to n minus 1, I will check all of that, and all three condition gets false, then I will check my final condition, or else second last condition, which is if nums of mid is equals to nums of m minus 1. What I mean to say is that I am sure that this wherever I am pointing currently is not a single element, because it has got it has a duplicate element. So I am checking if that duplicate element is present on my left. Yes, it is present. So let's see now how I am going to decide whether I should move left or right. This is the main thing. Okay, 1 1 2 2, I mean 1 1 2 3 and 3. This is mid, and mid is right now 4. I have a 2 here, right? This is my answer, and 4 4 8 8. Yeah, it's okay. So suppose it was not present here. Let's say it was 2 was not present here. It was, I mean, something else was answered. 1 1 3 3, and like 4 is the answer, let's say. So now what will be the mid? I mean, index will change with 2 0 1 2 3. Earlier on it was 4, now it's 3. Why? Just because I don't have a single element, I don't have that element which is to my left. If it would have my left side would have a element, and that is a single element, then it would have been 4. It would have been a even number, right? But it doesn't have in my left, so definitely it will be an odd number. Like suppose it would have been a 2 here, definitely the index would have been changed to 4, right? So what I will try to do is that I will try to move to my left. So as per this, like according to this test case, I check that my duplicate element is present on my left, and my current current mid value is a even integer, so definitely I have to move to left. So I will say, if this is the test case, so I will say and is equals to mid minus 2. Why not mid minus 1? Because I know that this is not going to be my answer, so I will simply say mid minus 2. I will simply move my and pointer to this guy, right? I mean, and will be pointing and is somewhere else. I will point to here now, right? I hope you got this also. And if this condition is not true, I mean, if sorry, I should have written everything properly, I guess. If mid percentile, I'm sorry, modulus 2 is a 0, then I will say and is equals to mid minus 2. Else I know that I have to move to right now in this condition, because if it is not present on my left, definitely I have to move to my right. So I will say s equals to mid plus 1, correct? Now let's say if it is present nums of mid, like mid is something different in this case, not this 4. Mid is something 3. Okay, let me copy it. Okay, so let's say our mid is 4 in this case. Not 4, 3. This is my mid. Now my duplicate element, my duplicate brother, is on my right side. Nums of m is equals to nums of m plus 1, correct? Now how will I decide? Now the condition will change here, like on my, if m modulus 2 is equals to 0, and in this condition I was going to that left side, but it will be different here. So let's see what will be the difference. 1 1 2 and 3. Like what is the mid now? Mid value, it is 0 1 2 3. Mid is 3, and as you can see, the single element is present on my left side. If it is 3, if it is an odd value, then definitely that single element is present on my left side. If mid modulus 2 is not equals to 0, so simply means that it is present on to my left side. So I will do and is equals to mid minus 1, not mid minus 2. Why? Because I am at this position, right, and my duplicate element is at this. Why I will do mid minus 2, right? I will simply say mid minus 1. Okay, now if it is not, then I will say else s equals to mid plus 2. Why plus 2? Because I have 3 on my right side. I know that if I will move s equals to mid plus 1, it will be pointing, my s will be at this position, and I don't need to do that. I can just skip 2 points, right? I know 3 is not going to be my answer, so I will say simply s point it here. This is the whole complete logic. I hope you got this, and if you have any doubts, you can just comment in the comment box. I will definitely reply. So let's code this solution, right? N is equals to nums dot size, and if n is a single element, I mean nums array is a single element, I will simply return nums of 0 as an answer, because that is going to be the answer, correct? Int s equals to, now start and end pointer, int e is equals to n minus 1, and while start is lesser than or equals to end, int mid is equals to, I am going to find the mid value using simple this formula. Now so let's write each and every condition that we earlier discuss. Okay, so I will first check if mid is a 0. If mid is a 0, what I am going to check is that and nums of mid is not equals to nums of mid plus 1. I am going to check if the 0th guy, that mid is 0, right? I will check mid is, and nums of mid is not equals to the nums of mid plus 1, then simply nums of mid is the answer. Nums of mid is the single element in our case. Else if that n minus 1 wala case. Okay, if mid is equals to n minus 1, then I will be checking my second last element. Nums of mid is not equals to nums of mid minus 1, then nums of mid is also the answer here. And else if suppose it is not, mid is not pointing to the 0th position, and mid is also not pointing to the end position, so I can simply check my left guy and right guy, right? I will simply check my left guy and right guy, and I don't need to write if mid minus 1 is greater than or equals to 0 and this much, because I have already written here. That's why I wrote this line of code before writing this line of code. Okay, I will say if nums of mid is not equals to nums of nums of mid minus 1, okay, is not equals to nums of mid, and if nums of mid plus 1 is not equals to nums of mid, so definitely the nums of mid is the answer. Well, you can combine this all the test conditions into a single condition, but it will be a mess, so I wrote them separately. Now the main logic comes here. I will check first, I will wrote this condition, if nums of mid is equals to nums of mid minus 1, else if nums of mid is nums of mid minus 1, they both are equal. What I am trying to say is that my duplicate brother is present on my left side. Now I will check, is mid even or is mid even or odd. If mid guy is present in a even condition, so where I have to move, I have to say and is equals to mid minus 2. I will move to my left side, else as start is equals to mid plus 1, right? Start with now the final condition remains, and that is my duplicate brother is present on my right side, right? And for that, if mid percent modulus 2 is not equals to 0, mid modulus 2 is not equals to 0, where I am moving, I am saying start is end is equals to mid minus 1, and if it is not the case, where I am moving, start is equals to mid plus 2, right? So I think I have completed the code. I can simply return -1 if I don't find anything, but definitely there is a answer according to the question. Yeah, there will be always a single element. So the time complexity for this solution is just O of log n, and as we are not dealing with any extra space, though the space complexity is also O of 1. So let's run this. Yes, no errors. Yeah, as you can see, my solution is submitted. So I hope you guys you got the solution correctly. Thank you for watching my video. Thanks.